Okay, we're on to the next part. Welcome to part 7 of our Chrysler, the big 79-5A chassis. And let's get the chassis back in here. First of all, thank you to all my subscribers, to all the people watching my videos. I hope you enjoy them. Sometimes they're a little bit long, and well, you just got to skip over to the parts you like. Sometimes I detail little parts that you may miss if you do that, but that's up to you guys. So, as I said, thank you very much for watching so far, and thank you very much to all my subscribers. I just hope you enjoy what I'm doing. Righto. First of all, we've got to get our chassis put down into the TV here, as well as get this ready to mount up in the side here. So all this has to be done in sort of the one hit. Nearly forgot. We've got to put the aerial socket soldering back on the tuner, which is no big deal. And then, yeah, I'll record some of this going back in. I won't be doing much talking while I'm doing that because, yeah, this thing's a fairly heavy, delicate situation. I don't want to break any valves or anything in here. All right, that's where we're up to at the moment. Let's get this lot in there. Okay, everything is now sitting in place. I've put a screw up there, a screw down the bottom, and a screw in the side, our mounting points. Our tuner assembly is all screwed in and secure. We've got a fine tuning knob on the front. That was the only thing that I had to put on the front. In here, up the top there, we had a ground lead on our tuner that goes across to our grounding around the tube. There's a little wing nut in there and a little bolt that secures that fella. Now down here, haven't done anything other than push this in for you. I want to just bring you on the journey. I don't know what else is wrong with this, so I have no idea. Our yoke wire, for the moment, we don't want to plug that in just at the moment. There's a couple of things to do. This is our CRT socket for the tube. And once again, I'm explaining this for the newbies out there. Yeah, the old timers that are watching this, you know what I'm doing. Now, here, normally this is mounted here and your remote control plugs into here. Now, when you plug it in, I'm not sure of the circuit, it disables a couple of contacts here. Now, when the time comes, I'll bring this a little bit closer so that you can see what's going on here. Just going to take those contacts off here and clean them. I'm pretty sure it's carrying AC to the power switch, maybe. I don't know. We'll once again have a look at the circuit and just see what that actual switch does. But anyway, I want to clean the contacts, clean the socket, and then we can mount this back on our choke that's over here in the power supply section. Now, there's a little bit of rubbish around the bottom of one of the main cans. I will be replacing both of these. Restuffing, probably. It's probably easier. They're a nice big cap. The new ones fit easily in there. So we'll probably restuff and mount them back as they are. I think that'll be a better idea. It'll look more authentic, but easier to deal with anyway. I'll plug the speaker in. Just goes in the side there. What else have I done? Not much, really. I've reattached that label and this label. They were peeling off. That's about it for the time being. There's a couple of things I have noticed. But yeah, no, I won't show you that. We'll get on with this, fix that up, and then we'll move over to the horizontal area where I'll show you. There's a little bit of a hassle. All right, so there she is so far. Now this is the switch I'm talking about. The socket there, fairly dirty. We'll clean all the contacts up, and we've got this little switch here. Now, if I can, just a moment, I'll show you how this works. For all those who have never seen one of these. Okay, when you plug the socket in from the remote, pushes the center and lifts the contacts there, as you can see. So it's a little washer across two contacts, just lifts him up and breaks contact. Now, when that breaks contact, I'm not sure. I think the power then, maybe this is a solenoid power for the on-off switch, and when it's broken, these cables go up to your remote somehow. Well, this one does, and the remote does the switching rather than this. I'm not sure, but anyway, there he is. So let's take this apart and just clean the contacts here so that we know that won't give any more problems. And we're just taking the contacts off. I did try and undo this center screw here, but boy, he's tight. Anyway, these are our contacts. They don't look too bad. We'll try and clean under the little washer. As you can see, it's just a washer on a plunger, but I really can't get that fella out. He's, hang on, he's a little nut. He's a nut on the end of him, but I haven't got anything that'll go in there. Let's leave him there and just clean around the bottom of the washer here. Small bit of wet and dry, just sit him in under the washer there and spin him around if we can. And of course he doesn't want to. There he goes. It'll just make sure that it contacts seeing the remote. Well, we don't have it. I don't know whether we're going to round one up. We probably will. These fellas. And yeah, he's back there. So let's put a meter across this and make sure that little fella's working. Meters on continuity. Put him on here and here. We should have continuity. And there he is. Oh, and just a little tip for a catch-up. For the guys who obviously don't use fluke meters, when I've got this on diode check and I want to test capacitors, I push this little yellow button here. This goes to capacitance check, and then we check our cap, even though it's on diode. So, okay, there's been a couple of comments, and obviously they're not that familiar with the fluke motors, but that's how they work. We press the yellow again, it goes back to diode test. Okay, so just a trick with the fluke if you're not familiar with them. What we've got to do now is clean up this chassis. So just it's pretty good on top. There's no real grotty, horrible grease or anything else on this. It's in pretty good order. So it's a matter of going in here with some alcohol or methylated spirits or something, with either my makeup pads or my little cotton buds or something in here, or a paintbrush, and get in here and clean up. Now, there's a fair bit happening in rubbish and that in behind here, so we're going to just clean the whole thing up. Now, where I'm starting on this, there's a lot of rubbish in behind this shield here, which is just near the line transformer, the EHT transformer. Just going to take these two out. Now, I've noticed that cable there, which is to our 6AL3, is split. I'd like to replace that cable. And yeah, we'll unsolder these, push them back out. There's two screws here. Now I think I can bring most of this forward, so we'll take the valves out, and it'll make this area a lot easier to clean on this side of the transformer. Certainly don't want any fluff or dust left around the transformer that can attract moisture later on and arcing, and then you start losing transformers and so forth. Okay. Now I think if everything goes back with these cables, I think if I lift the transformer or unsolder these fellas, it's a bit of a, because the transformer is just screwed down to the chassis with 4 screws, I think. Yeah, 4 screws. It'd be good to get the tranny out and clean him all up, because he's got a lot of build up of rubbish on him. So I might unsolder these fellas. Yeah, I think I'll unsolder this plate and take the tranny out. We need to get this thoroughly clean. These cables here, as you saw, they've got to be cleaned up. You got bits like that happening that are broken. So just a bit of high voltage cable there. There's there's probably 3 or 4,000 volts sitting on this one, and I'm not sure on the AL3, probably 1200, 1500, something like that, but very high spikes. So all in all, this has got to be cleaned up. I think I will. Yeah, I'm just thinking as I'm looking at this, I'm going to remove all this, and this area has to be nice and clean. I want this, like, it's grotty in here. I want this cleaned up. All right, we'll do some drawings and make sure, and photos, and make sure I know where everything goes before we start unsoldering things. Should be pretty straightforward. Should be. Yeah, right. When has electronics ever been straightforward? So there you go. That's in behind there. That's what we're looking at. And yeah, just get him all cleaned up. The 1S2 here, well, yeah, get his base, clean it all up, make sure everything's right underneath. This is an important area to make sure that there's no dust and dirt in here. It causes excuse me, it causes problems down the track. So yeah, all right, we'll start drawing out our little diagram and taking some pictures. We'll go from there. Righto, we've got all these undone and documented. We can check this resistor, these resistors, there's a varistor there. And under here we can also check just a couple of things. I don't really want to undo these. I don't think it's necessary. I think we're right there. It's cleaning all this up and we can get it out of the road here. Although having this out of the road would have been handy. Anyway, now what we've noticed here, our 1S2, there's his cap. So it's come adrift from the wire on top of the 1S2. Okay, so we're looking at a fair bit of voltage on the top of that. So that is something that certainly was good to find. Well, eventually we would have found it. Just take him out if I can. There we go. And as you can see, we'll take the top out, get him out, and a bit of JB weld to probably remove all this and resolder the top. If it's not broken, I don't think that wire is actually broken. I think there's enough there to pierce through the top when we put him back in. He seems to be sitting on the wire, so there's enough to go through the little hole in the top there when we desolder him. So you can probably see that he's in there anyway. All right, so there's one little job for us to do. Right, the next thing is we remove this transformer and our 1S2 socket, and everything comes out with it, our filament winding, the whole business. Okay, get our plate out. There's our transformer. And looks like this fella's just floating around there, but he's actually, the base is actually broken, so something there we've got to fix as well. Okay, now I've got to unclip our high tension lead. We'll just unsolder him. And after this is done, I'll show you where he was connected up. There we go. Right, connected just on there, on the ring. Okay, so that's our, what would you call it? 1S2 rectified output DC to the tube. That's our line that goes to the tube. I can get him out. There we go. So he goes up. It's about 16 kilovolts up to the tube. Now this fella, he's got a broken piece down the bottom. That little screw there is actually mounted in a piece of bakelite, which attaches to the bottom. So we've got to remove the bottom of the 1S2 socket, or the base assembly, and have a look at him. Righto, there's our transformer. A little bit of wax around, not too bad. Hopefully everything's okay there. All right, so we've got to clean him up. Makes a bit of space in here for cleaning up anyway. Okay, so what we've got to do now is tip the chassis up. I'll have to put a couple of screws in here so we can anchor the chassis, get underneath, and work out. I'm not sure how this is held in here, the base of the 1S2, so we can repair that little fella. So yeah, a little bit of repair work. Also, while we're doing this, we'll probably check those caps. There's leakage around that fella especially. But yeah, just general cleanup in this area and check that. All right. Okay, guys, I was going to remove this base assembly for the 1S2. This base assembly has been melted into position. There's 3 protrusions go through the chassis underneath, and it's been melted on there. So the chances of getting this off, I don't want to risk it. It'll break it. So we'll clean it up where it is. We'll try and fix the center of that, the spindle and the actual valve socket where it is. And then we will put this back together in situ. We'll clean up all around it, and yeah, we'll go from there. I don't want to take this off. It'll only lead to a problem there that's very hard to fix. Okay, let's have a look at the rest of it anyway, and I'll show you what I mean. It's our line transformer. It's our 1S2, and yeah, we've got a little screw in the center of the 1S2 socket that goes into there, threads into there. Now, this socket should be part of the base assembly, and yeah, I don't quite know how we're going to do this one. Well, let's try and unscrew this and take this off. Okay, he unscrews from there. Now, can we take him off? Yes. There we go. So there's the piece that's broken off the base. Should be able to super glue this back onto the base assembly, and then just sit this back on there. I'm pretty sure we'll be able to do this. Righto, let's have a crack at this. All right, you can see the base assembly there, and it's only a matter of super gluing that little fella back on the center. Just find out how he's come off, and yeah, it'd be good to be able to hold the socket down. I mean, it's loose. It's probably not going to go anywhere, but yeah, just in case it does go somewhere, yeah, I'd rather glue this in. Anyway, let's clean this area up a little bit here. There's yeah, a little bit of rubbish down there. Well, that was a bit of an exercise with this one. I went to glue the little piece on the center of that, and which is this piece here, but he's fallen to pieces. It's I don't know whether, I think this is just plastic, and as you can see, where are we there? As you can see, this little fella just fell apart. So I couldn't glue anything onto there. I don't want to drill a hole into the bottom of this and screw this into the actual base, because if I put a hole in there somewhere, there's a chance of arcing out. because we're looking at 15,000 volts and 16,000 sitting here, and it can arc onto the chassis through the bottom of this. So we'll just leave it as is. We'll put it back in. I'm going to put a couple of cable ties both around the HT and the filament winding of the 1S2. So that should hold everything together. So we'll do that, and that will have to suffice for this fella. It's not going to make any difference when the top goes on, which there's the top. When the top goes on, the 1S2 is held by the top anyway, so it can't move, it can't get out. It's just a shame that we couldn't fix that. Yeah, just that little broken bit. Someone else fairly heavy-handed's obviously been in here and, yeah, probably tried to pull this out without undoing the screw and broke the centre spindle, the plastic spindle. I'm pretty sure this is just plastic, actually. Yeah, but either case, we do not need an arc between there and chassis, so we'll contain him in here. Righto, we'll do this bit, and then we'll start connecting up our line transformer that we've just got sitting there at the moment. He's only got to have a screw in him, and then we can start connecting up back to here. Okay. Now, before we start putting this all together, we'll check the resistors here. Now, this fella, fairly big resistor, I think. I don't know whether he's a resistor or a cap. I'm pretty sure he's a resistor. I can't see any markings on him. But no, he must be a cap. We'll have a look at the circuit on him. One in here, which is a 1 meg, brown, black, green. So 1, no zeros, and another 5 zeros. Brown, black, green is a 1 meg. And 1 meg, spot on. This fella, brown, black, green, same. Let's check him. 1 meg. So we know they're right on this side. So we can now start soldering these up and putting them together. Purple. Also purple from here. White. Top one. Him. Black. Tag strip. Black. Tag strip. That one. Purple. Goes in here. That one. Let's excuse my throat at the moment. I've got a bit of a cold. Let's got our 2 high voltage leads on. We'll thread them through here. And now what I want to do, because all the cables are behind here, holding it out a little bit, just going to put the heat gun in there and soften things up a bit so that it all finds its place when we're pushing it back in. I normally do this with plastic cables, just so everything sits in position nicely. I'll bring this back out a little bit on that so you can see what I'm doing. There you go. Not much to see. But just heat the cables gently so that we can push it into position. That would be enough. That's good. That's a little bit nicer. Now we've also got to put the screws in the bottom of this, which is attached to the bracket on the line transformer. But main thing is get the 2 front ones on here to start with. Now with these fellas, this cable I'm using is a little bit bigger than the other cable that was in here. So rather than going through that hole, what I'm going to do is cut it at the right length, solder him on, and put a cable tie through the hole to hold him on the top there. That will never move. Doesn't really need to go through the hole. The cables, yeah, it's just a bit stiff to do that with. So that's what I'll be doing with those. Well, there we go, guys. Those 2 are on. This cable's a bit stiff to cable tie him onto the PCB there, so I've just taken him up. That will never move. This really will never move. They're nice and tight. Cleaned the sockets, the bases, as well as the oscillator base. So this section here is pretty good. What we've got to do now is fix the 1S2, which, as I showed you earlier, has the top cap missing. He's just come off. So hopefully we can resolder this and he can go back in, and then that's more or less this little horizontal output unit finished here. As you know, we've had this running, so we know the transformer works. Well, it did before I had it all pulled apart. But I'm sure that I'm sure things will go okay here. So, yeah, we'll do this one now. Okay, there's our cap. We're going to leave this glue in here because we're going to put a little bit of JB just in the top of him there on this glue as well. So the whole thing will stick fine. So let's try and get some solder off the top of him so that we can see the hole to put our little wire through. This is on the top of the 1S2. And if you're not sure about a 1S2, it's a high voltage rectifier used in lots of sets. You've probably seen 1B3s and tubes as such. So, yeah, this is just another version. Gee, there's a bit of solder in here. Just trying to get him all out. I should have used the solder sucker. Right. I think we can see the hole there. There he is. Okay. So there's our 1S2. Let's. I'm looking at the wrong picture here. Just got to keep an eye on what picture you're on. Just straighten that little fella out a bit. And he's a bit hot, but anyway. Hopefully we can get him up through the hole. I'll just check this before I put the JB on there. And yeah, we can, but he's sitting up a little bit because he's actually resting. I'm not real sure about this fella. But he was working. He's actually resting on that little indent. Oh, there he is. Yeah, and I can just see him there. All right, we will use some JB. Put him through and just make sure the epoxy is holding, and then we'll solder him up. Okay, well, here's our 1S2. Some JB weld around the top and soldered him up. And yeah, that's fine. Let's put him in. Right, guys, well, she's just about ready to fire up. Now, what I want to do before we do that, yes, we can chase out the faults and everything, but before we do, there's a blowy in here. I want to do some ESR checking on the filter caps and check them. There's a couple of filter caps under here, and this is our voltage doubler circuit from the transformer. So we'll go into that and show you the circuit and so forth when we get to that. But first of all, just check the caps. I will probably have to replace them. We'll check and just see what the ESR is and what they're reading, just to see before we get into the nitty gritty of having the whole thing, well, fired up, working, and then possibly looking for other faults, be it audio, video, yeah, whatever. We've also got to check the tuner assembly and make sure it's working as well. So yeah, let's tip it upside down now and get onto these caps. Now if we'll tighten him up a little bit just to make sure that he doesn't move. These were pretty good to service actually, being able to do this. Okay, now as you can probably see, we'll get a closer look in a moment. There's your two main filter caps for your voltage doubler circuit. A couple of diodes there, but we'll get a little bit of light on this, a little bit better light, and get you closer in on that shortly. The other two caps up here, which is underneath here. So we'll do the ESR test on those two and these two, just to see what they're like. Right, guys, the first one here, we'll have a look at this fella here, which I think is a 50 microfarad, 400 volt or something like that. Let's see. What is he? 1.2, 1.1. If I can get a decent. He's actually, he's settling down 0.7. That's a good cap, that may have been replaced at some stage. But anyway, here's the next caps here. Now I'm not certain of the values of these. We'll just have a look. I think they're 50s, I think, but I think they're only 200 volt or something. Anyway, we'll check him out in a minute. Well, that one, I'd say he's open. This one, I'd say he's open. This one, I'd say they're open. Am I doing the right thing here? This one? No, I'm not. I wasn't on a good ground there. Hang on. Let's see here. This one up the top, 0.6. He's good. This one, I'd say he's open. This one, 5.8. Yeah. So this one, a little bit high. This one up here is 0.6, 0.56. He's okay. This one here, open circuit. Now we'll check out those caps. We'll check out the values, but yeah, I'm going to change these anyway. Probably before we go too much further. I would say this one has been changed. The original caps looks like they've been put through the chassis and twisted. It's got those little tags that you twist to hold them in. This one, I think, has had that at one stage, but probably replaced with this cap. Either way, we'll take these out and restuff them, I think, is the easiest way. We'll have a look. There's a bit of room under here. If I can get rid of this fella, say, and there's a bit of room around here. So we'll just have a look. And if there's enough room, there's a lot of mucking around restuffing them. And yeah, this isn't something that people are going to look and admire. It's not like a radio. So it really doesn't matter where the caps are. This one down here is probably a cathode bypass on the 6BM8, I think it is, on the audio output tube here. So I certainly would be changing him. What's he read? He reads open circuit. He does. He honestly does. Reads open circuit. Okay, this little fella here, he's 1.6, so he's not too bad. We'll look at this fella here. I don't know where these caps are in the circuit at the moment. We're just checking them. 2.2. Yeah, he's not too bad. Now, we'll move along over here. Hopefully you guys can, I'll bring this over a bit there. There we go. Okay, this fella down here, 1.7. He's not too bad, but of course he'll be replaced. This one here, 2.4. Not too bad. This one up the top here, 1.8. He's quite good. But yeah, we are replacing all these. So we'll probably do quite a few of the caps before I actually turn this on and yeah, and run it for a while, because I don't need bypass caps, destroying the tubes, especially a 6CM5 and things like this. We'll check those caps out. Now the big fellas, our big voltage doubling caps. These are, let's have a look. They are 200 microfarad at 200 volts. Nothing spectacular about them. So, what's that? 0.5, quite good. That's very good actually. Should we replace them? This one, 0.9, 0.7, 0.6. These are actually reading pretty good. So, should we replace these? I might have a think about those, because really, I will measure the capacitance on them shortly, but with an ESR of 0.5 and what's this one, 0.4, 0.4 for 200 mic, yeah, in around 250 volts, 0.5 should read, sorry, the cap should read in around 0.5 at 250 volts. And that's what we're reading. So the question is, should we replace these caps? Now, we'll have a think about that. Another thing here, in here, we've got a hornet's nest, or the remains of a hornet's nest. It must have liked in between these caps. He's actually gone in behind here. Yeah, I think I'll unscrew the bottom of this. I think they unscrew from the chassis, and we can lift him up and get this hornet's nest out. As for replacing them, well, yeah, as I said, check the capacitance, see what they're reading, and the ESR is good. Really, there's no need to replace those. These fellas over here, on the other hand, are a totally different thing. Okay. let's see if we can get these out easily. I'll just, yes, they do. The base unscrews. And yeah, there we go. I'll give you guys a little bit of a look at this fella. Yeah. So there he is, all in there. A few spiders in him, old dead spiders. Yeah, he certainly found a nice quiet little spot for his nest. I don't think there's no more up behind him there. No. Oh, good. Yeah. So there he is. As you can see, you can unscrew the base of these. Now, just looking at these, they're in a pretty bad state. They're starting to deteriorate on top. Show you on top. You can probably see him there. Yeah, I think we'll replace them. There you go, 200 mic, 275 peak. So we can certainly get a couple of caps, good caps, out of a computer power supply, which uses a voltage doubler in the circuit. We might have a bit too much light on there, I think. Just back yours off a bit. You wouldn't think you could have too much light, but there appears to be. Right. We'll clean these up. I think I will replace them. It's no problem to mount another cap just in here, and a little bit of, well, Celastic actually would hold him in there, or rubber tube around him and put him back in these. Yeah, we'll change them. We'll start here and work our way through with the electros. Right, we'll go and get a couple of caps and work out how we're going to mount them in these. Now, being a voltage doubler, this one's on the negative side. Now, those two are joined together. This goes down to the positive of the other capacitor. So, while we're doing this, let's have a closer look at the diagram of this voltage doubler circuit so that you guys know what we're dealing with. I'm not going to go into theory of how these work. There's plenty of YouTube clips like that. I'm not good at explaining theory. I just know how it works. So, yeah, let's have a look at the diagram. I just thought I'd show you a little bit of trivia or info or whatever you want to call it. There you go. This thing's about 120 mil high, I suppose, 110. And yeah, fairly big cap and being held in position by that. Okay, so 200 mic at 200 volts, 275 peak. and made in Australia. There's something you don't see. But this, what we're replacing it with, 220 mic at 400 volts. How is that? And the bonus is it fits into one of these little cups, and yeah, that'll be nice. That'll save a fair bit of space on the inside of this. Yeah, I just thought I'd show you that. These are newish but second-hand caps. These caps are absolutely brilliant. So yeah, we'll throw these in, and I've put the 100k bleed resistor across. Now the bleed resistor, of course, as it says, bleeds the voltage out of the capacitor once it's turned off and settles things down. So well, one advantage, you don't get zapped and half killed when you touch these after it's turned off for a little while. Of course, you don't go touching these if you've just turned the set off without discharging them properly. Okay, so if you're working on this gear, especially TVs, just beware that there's a lot of high voltage in these things. Unless you know what you're doing, just leave it to someone that does know what they're doing. Okay, so there's all sorts of voltages in here. Yes, this is a standard power supply, but it's got a fair bit of juice. There's a fair bit of current in these things, and if it nabs hold of you, it'll hurt. It'll hurt bad or put you in hospital. Okay, we'll get on with it and mount these up. Righto, got these two caps in. A little bit of difference in size with these fellas mounted in there, right across there actually, and these little fellas pushed right into the mounting caps. So yeah, a nice neat little job those caps make compared to the big fellas. Righto, let's move across to the other side and do the big fellas over the other side. Right guys, we're going mobile. There's the caps. Okay, now I hope you can see okay. There's not much light in here, but yeah, this one here, we've just undone him. Ground goes to the ground point there, and this one goes across onto this cap here. So has this been a replacement cap and just doubled in with this, or what's the go? I'm not real sure about what's going on. We might have to refer to the circuit before I go any further here, because those two, were on there, but why two caps and they're joined together, unless they were looking for a little bit more capacity. But thing is, this has had two screws put in it. They certainly don't look original. This hole is original, but it doesn't look like anything has ever been put in that hole. Just looking at it there. So yeah, I'm thinking, well, this cap over here probably failed, and they've doubled this in with it. They've just shoved this one on to keep, well, this one going. But of course, it's still in circuit, which is just a no-no anyway. All right, so, and there's little spindly wires and everything on this. There's a little bit more investigation to do here. So obviously, there's been repair work on these fellas. So let's get this one out and we'll have a look at the circuit and find out what's going on. Okay, looks like there's been a couple of things going on here. Now, what's this one? 150 at 400 peak. And we've got a whole heap of corrosion down in there. What's all this corrosion about? Yeah, okay. A little bit needs cleaning up there. And let's go and get the circuit. And by the way, we'll measure the capacity and just see what he's like. See how many microfarads is he? Supposed to be 150. Where can you guys see this? There, sorry. Okay, 150, 152, 151. That's pretty close, isn't it? So it doesn't look like all this rubbish has come from this cap. I'd say this cap's been put in at some stage to cover what was there, what actually leaked. So okay, the saga continues. We'll have a look at the diagram now. This is a terrible setup. As you can see, there's that's the red wire that, oh no, B plus, I'd say, well, one of the B pluses goes down here to this cap, which goes across to the plate of the 6BM8, I'm guessing, because this wire here, up here, is the red wire to the audio transformer. It looks like it's been replaced, and the blue wire, well, laying there, yeah, the transformer's been replaced. This set of, yeah, we'll pull all this out. Let's have a look at the circuit anyway. Here we are. We've got this capacitor, these two here. We've got this one worked out here. This one is C4 and this is C3. Now, this is hence C4, C3. C4 is our main filter cap, which is this one, the one in question, which is 100 mic, 150 mic at 350 volts. Okay, so yeah, this is the one. That's our main filter cap. It goes here. Now, on our circuit, let's have a look. Okay. There he is there. This fella here is C4, and he's on our actual main HT line. So we've got a fuse here, diode, and this is a separate supply. So it goes through another fuse, a half amp fuse, through our choke here, and comes to here, which is our center point for lots of feeds. So we've got a 230 volt feed off this, a 175, a 210, and a 170. Strangely enough, how I was looking at it as well, is that this one here, the 150, also ties in here, but goes straight down here to the 50, which is C3A. And we've got C3A, C3B, and up here, C3C. So that's all one cap, 50, 50, and 50. And yeah, strangely enough, I thought, well, why would they be connecting the positive line of your 150 directly to your 50? But it is. So in actual fact, it's a 200 mic cap, and yeah, well, they're in the same position. Well, but they're only a couple of centimeters apart. So yeah, it's a matter of capacity, I guess. So what we've got to chase then is the 8 and the 16 a little bit later on. But at the moment, this is our supply. This is what we're working with. Now, power comes in here. That's our on-off switch. Various taps for your various voltages. 6.3 volts. Now, this would be for your heaters. I'm just going to make sure. I can't see the monitor from where I am at the moment. So the 6.3 is for your heaters. This 6.3 is also on part of the 175 volt line, but that is for your picture tube, 6.3. So it's a totally isolated supply of 6.3 for your picture tube. Okay, so nothing to do with the 6.3 that that is for your rest of your tubes or valves. Okay, so that's about as much as I can tell you at the moment. And if we go over to the other side, this is our audio circuit. So our this is what I've been chasing here. Our what is that? 215, 215, I think. As I said, the monitor's behind me. 215 goes up here to the plate of your 6BM8. 210. So those two supplies, 210 here, they're all in this area anyway. That strange cap that was added in that I just showed you a while ago, which is this fella, he's a 0.68. Okay, now that was tacked in on that red wire between our B plus and direct to our plate. I have no idea why that would be there. So I've taken it out for the moment. It could have been modification. I really don't know. But anyway, what we're going to have to do is work on this. We've got 350s and a 150, all in around 350 volts, 400 volts to find. Whether I repack or, do them separate. There is room to do them separately, and I think there's room underneath. So anyway, we'll have a look at the whole thing now that I've sort of explained what caps we're working with, especially this 150, which is your main B plus. So guys, with all this stuff worked out, with our diagram of what goes where, let's get this second cap out, which is actually C3, to replace the 350s in there, which will be 347s at, something over 300 volts, I guess, 350 volts. Right, guys, now what I've done here is I've got a 150 mic at 400 volt. We've mounted him in the space of where the other one was. There was also one here, as you know. Probably not replacing that at the moment. Don't know. We've got to put a tag strip in here to mount a couple of caps in underneath. But this one is the 150 at 400. That's your main filter cap. And now we've got 347s to deal with, which I'll see. I think there's space underneath for all those. This is our positive line, which is this fella here. And now we're going to go over here and get something in here. Maybe a tag strip. I do have an earth point here. And if I can put a tag strip along here, we can put in like the 47 mics I'm looking at that are 450 volt are these little fellas. So, they're not very big. And if we can mount them in here somehow, I don't know how yet. This one will be coming out, and that's just our bypass cap for the audio. So, possibly mounted down along the side there. Just, somewhere a little bit out of the road. But anyway, we'll see what we can work out here. Well, guys, we've fitted up a few things here. We've got some caps in. These fellas up here, as you've seen. Now, what I was working on was that couple in there. So we've put two in there, and then, as you can see down the bottom there, if I get out of my shadow, there's the two longish caps right against the side in there. Yeah, we've got another filter cap there, cathode bypass for the sound, another cap there, which is HT3, 215 volt, I think. And back up here, vertical. So we've got a cathode bypass cap and another couple of caps there. I made them up. There was a 16 in there. I wanted a 16 to go back in case we had any vertical hassles or anything. So really, that one, checked him out and he checks perfectly. And I was short of 16s, as you can see by the one up the top there. So I thought, well, we'll leave it for now, and that's it. Now, I haven't changed the waxes yet. I'm going to try this before I do the waxes. They're this one up here, he's a 0.056 and he's rated at 1600 volts. So obviously in the horizontal circuit there, probably the focus or the width or something. Haven't looked at the circuit on that one either. So yeah, we'll check out, see if they're leaky, if they're okay. But really, I think we're ready to actually put the chassis down and we'll give it a run. Now, I will monitor the HTs, especially that HT right there. That's HT1 should be around 250 volts. So we'll monitor it. We'll start it up very, very slowly with the dim bulb and the variac. Probably 200 watts on the dim bulb, maybe a bit less to start with, and just see how she comes up. All right. So let's give it a crack, eh? We'll start putting it together and turning it on. See where the smoke comes out. See if I've got everything, especially those electrodes, the right way around. Hopefully I have. Okay. Now, you'll probably see a few shadows. It's very dark in here today. It's there's rain around and yeah, the workshop's pretty dark. And this is not the normal position that I'm working in. So just excuse me for a moment. Loosen him off. Right. Okie doke. Right. Speakers connected. It's time for the EHT cable. Our high tension to the tube. Okay, so we'll put him in. Like so. Our ground for the tube goes back over here and is actually held on there by a nut, which, well, I haven't got at the moment. We'll use another alligator clip just to get this all happening and see what happens. So now we've got, I'll bring you guys in a better, probably a bit better position, although that's not too bad for you. And I wonder who's betting on whether it's going to go or not. I don't know. Certainly haven't tried it since I've changed a few caps. So hopefully I've got them all right in the power supply. Our yoke plugs in down here. Now I haven't cleaned all the valve sockets yet either. I've done these three and it's just all the valve sockets that I've done. So they still have to be done. But I want to make sure that this old girl's going to fire up before going any further. Out here, our CRT cathode ray tube, or picture tube, as they're known as. Okay, we won't tidy that up too much. What else is there to connect? Okay, where can we sit this where you can see it? There? You guys see that? I think so. I don't think there's any. I don't think there's any glare on that. Tells us what the HT is. Okay, now HT is here. We are now plugged into the dim bulb 1 and 2. So we're looking about 160, 180 watts there. But I do have 0 on the variac at the moment. What I'm going to do now, make sure she's turned on. Let's crank a bit. Okay, 100 volts and on. She's on dim bulb, and it looks like we have HT. We'll just let that build up a little bit. We're up to 140 on the variac and coming up to 100 volts on the HT. Wiggle my sound valve around, and yes, we do. Okay, we have activity. How many EHT? Nothing yet. That's fine. Okay, 210, pulling 70 watts. Up to 240. Okay, that's pulling 90 watts. No voltage there. 136 on our HT. Still very low, so probably nothing's going to happen yet. We don't have any high tension yet. We will back off for the moment and put a bigger lamp in, which is a 150 watt. And we're up to 240 there, drawing 100 watts. We do have some sort of EHT. We have a whistle in the speaker, which is interesting. Let's turn the audio down. Still on dim bulb, and we're on 190 volts on 210. We've got 137 on the HT. Tubes are alight. Do we have EHT? Now, what I'm touching here, guys, be very careful when you're doing this. I've done this a long, long time. So use an insulated screwdriver and just see have you got any arcing on top of your high voltage rectifier, which is a 1S2 in this case. Nothing yet. 135. Let's take her up a little bit more. And I don't know why we have a whistle, because I haven't touched the audio transformer. Okay, so what we do now, I'll unplug the speaker so that we can take her up a bit further. Nothing appears to be smoking or hot. Do we have any EHT? Slight amount. Our dim bulbs are fairly well restricting there. We've got 108 watts out of it at the moment. So we're probably going to have to go off dim bulb now and just bring it up with the variac. Hasn't got enough oomph there to get things moving. Can't hear the vertical. I don't think. Vertical tube is hot. We're going to bagger off and we're going bypass. We're on bypass. We're on 140 volts, 150 volts. So we're direct mains there through our isolation transformer and our variac. And I'm just bringing it up slow. That's 170 volts. We've got 170 on the HT. Now 6CM5 is not red plating there at the moment. We do have a little bit of EHT. So I'll bring the probe out later and show you how we test the DC voltage up on the tube there. 135 watts at 200 volts. Got quite good EHT. So we're not real sure whether we've got a picture yet or not. I'll just have a little bit of a look. And yes, well, we do have something. Now, I really want to show you guys this. Anyway, we'll take him up a little bit further. We're at 220 volts there. Okay. We have good EHT. We're on 200 there, which is pretty good for the HT. We know everything is working. How can I get yous around here? What I'm going to do, I will take the meter down. Okay. Here we go. And for the moment, I'll turn my bigger light off if I can get to it. There we go. Now, guys, guess what? Look what we got on the screen. Yeah, she's a bit narrow and a bit small, but we're not at full voltage yet. We've got a light here on channel 1. We don't have any volume at the moment. We do have a screen, a little bit out of focus. It's normal because our voltage is actually a little bit low and, well, haven't set the voltage. You may see some funny stuff going on the camera, some flickering. That's not happening in real life. So what do we got here? Horizontal hold. We have brightness. Tube's not too bad. Hey, she's not too bad. Okay, we got brightness. Where? Contrast. Yeah, tube's not too bad really. Now there's a corner missing here. Not quite straight. This is all stuff that we've got to do now. I'm just pretty stoked that things are happening on here. That's the main thing. All right. Well, as you can see, channel 1's lit up. I'm fairly impressed with that. Righto, guys. I'll call it a day today. It's what is it, about 6 o'clock in the afternoon or something, and it's probably 1 o'clock for me. So yeah, I might go and have a wine and celebrate at least seeing a raster on the screen. It's got snow, which is a really, really good indication that the tuner's working, the IF section's working. How well, we don't know, but we will know when we get a picture on there. And yeah, then we can align things up. So I'll put I've got an Alanya generator here that we will be using to set up. I'll just show you guys what it is. This is what we'll be using to set the gear up with. Okay, so it's just an Alanya. It operates on channel 0, 1, 3 or 4, I think. It's all 4 channels. So, yeah, there we go. Righto, guys. It's a wrap for today. We'll catch you tomorrow morning when I'm very excited about getting this going with a bit more power to it and, yeah, get this picture pretty good. Okay, we'll see you then.